Okay, so what are we going to do for this is we're going to try to use some of the identities that we did in class to uh, to help us with this. It says use the identities to find the exact values of the sine of 17 pi over 12. So what you have to do, oh, and the cosine of 17 pi over 12. So what you have to do is you have to think about, okay, what what identity am I going to use? Well, I'm going to probably use the addition one, and I got to think of what two things could I add up to make 17 pi over 12. And you want to think of the ones that we know. So, like pi over 3, 2 pi over 3, pi over 6, all those. So, what we have is, in this case, I guess this is actually equal to, this is actually equal to the sine. This is actually equal to the sine of, it's equal to the sine of 2 pi over 3, and there's another one. So this is equal to the sine of 2 pi over 3 plus, I believe, 3 pi over 4. And if you do the arithmetic, I think it works. And then you're looking at our foldable, so then sine of 2 pi over 3 plus, that's this addition one. So sine of the first angle, which is 2 pi over 3, times the cosine of the second angle, which is 3 pi over 4. And it's going to be plus the cosine of 2 pi over 3 times the sine of 3 pi over 4. So what is the sine of 2 pi over 3? I believe that's radical 3 over 2. And what is the cosine of 3 pi over 4? I believe that is radical 2 over 2. Plus, what's the cosine of 2 pi over 3? I think that's 1 half. And the sine of 3 pi over 4, I think, is radical 2 over 2. All right, so then this is radical 6 over 2 plus radical 2 over 2. And then to simplify that, you realistically, I can pull out a radical 2 here. And so it's radical 3 plus 1 all over 2. So that's the exact, it doesn't look very nice. I'm sorry, that's supposed to be 4. And that's supposed to be 4. And that's 4. So it doesn't look very nice, but it is what it is. Okay, let's look at the other one. Cosine is 17 pi over 2. We're going to use the same combination. We're going to say, okay, this is cosine of 2 pi over 3 plus 3 pi over 4. And so using our foldable there, I believe this goes the cosine of 2 pi over 3 times the cosine of 3 pi over 4. So that, and then I think it's going to be a minus the sine of 2 pi over 3 times the sine of 3 pi over 4. So what's the cosine of 2 pi over 3? The cosine of 2 pi over 3 is negative 1 half. Cosine of 3 pi over 4 is negative radical 2 over 2. We're going to go minus sine of 2 pi over 3, I believe, is radical 3 over 2 times sine of 3 pi over 4 is radical 2 over 2. So when you combine these things, I think that's negative, or that's positive radical 2 over 4 minus radical 6 over 4. And so then this is like the kind of the same thing. Factor out that. So then it's 1 minus radical 3 all over 4. Doesn't look very nice, but it works, I guess. All right. Moving on. Find the cosine of x minus pi over 2 and the sine of pi minus y. So that first one, I guess, let's just use a subtraction one. This is basically the cosine of x times the cosine of pi over 2 plus the sine of x times the sine of pi over 2. So what's the cosine of pi over 2? Because the cosine of x we don't know. The cosine of pi over 2 I think is 0. So that's the cosine of x times 0 plus, what's the sine of pi over 2? I think that's 1. So 1 times sine of x. So then this just becomes the sine of x. How about the pi minus y? Well, this one we're going to do the sine of pi times the cosine of y minus the cosine of pi times the sine of y. Well, what's the sine of pi? I think sine of pi is 0. So yeah, it's 0 times cosine y equals, and what's the cosine of pi? 1. This is just the sine of y. All right, sweet. Moving on. This goes back to what we did before, where it says prove the cosine of x times the cosine of y is equal to 1/2 x, 1/2 cosine x plus cosine y. So I guess what I'm going to do is I'm going to deal with the right side. If I deal with the right side, I got 1/2, and then this I'm going to say that's cosine x cosine y minus sine x sine y plus cosine x cosine y plus sine x sine y, using just our foldable. And then when I look at this, cosine x cosine y, so then this is 1/2, and then if I'm combining these things, I got 2 cosine x cosine y, and then the minus sine x and the sine y cancel out, and then half of that is, there you go, boom, done. That was easy, right? No problem there. Let's look at another one. The tangent of 7 pi, the tangent of 7 pi over 12. Let's do the tangent of 7 pi over 12. So what are we going to use to do the 7 pi over 12? Well, let's do the same thing that we did before, and that is use the 2 pi. So I guess the tangent would be, you can use the tangent of, and I guess we could go with 2 pi over 3 and 3 pi over 4. So 2 pi over 3 plus 3 pi over 4. And then using your foldable, this would be the tangent of 2 pi over 3 plus the tangent of 3 pi over 4 over 1 minus the tangent of 2 pi over 3 times the tangent of 3 pi over 4. Okay, so to do it, I guess this is basically the sine of 2 pi over 3 over the cosine of 2 pi over 3 plus the sine of 3 pi over 4 over the cosine of 3 pi over 4, because that's what the sine or the tangent is, over 1 minus that, so I'll call that times this. And I'm just doing that because I don't feel like writing everything. So let's do this. Let's figure out the sine of 2 pi over 3. So they said the sine of 2 pi over 3 was negative radical 3 over 2. So it's negative radical 3 over 2 divided by the cosine of 2 pi over 3, which is 1 over 2. So what's that? Negative radical 3 over 2 times 2 over 1. So that's negative radical 3. So that's negative radical 3 plus the sine of 3 pi over 4. The sine of 3 pi over 4 is radical 2 over 2 over the cosine of 3 pi over 4 over the cosine is negative radical 2 over 2. So that's negative 1. So plus negative 1 over 1 minus negative radical 3 times negative 1. So this would be negative radical 3 minus 1 over 1 minus radical 3. So if I rewrite this, this is actually negative 1 minus radical 3 all over 1 minus radical 3. Doesn't look very good, but that's where we're at. So I think that's a good place to stop. We'll do the rest of the information in class tomorrow. So good luck, and hope to see you in class tomorrow, and may the force be with you.